Welcome to Geometry Honors, Liz Kaysen.
Okay. All right, so today we're going to look at parts of similar triangles. So we've been doing similarity from one triangle to another. We've also looked at yesterday, we had parallel lines, right? And how that divides the sides of a triangle into proportional parts. What we want to look at in this lesson is we're going to take two similar triangles and look at some of their special segments. So for example, like medians and altitudes and some of those segments that we learned about in our previous chapters. So the first thing, we actually addressed this earlier on in one of, I think it was 7.2 maybe, proportional perimeters theorem. Okay, so if two triangles are similar, then the perimeters are proportional to the measures of the corresponding sides. Okay, so what that means is we don't necessarily have to know the entire perimeter, right? We just need to know two corresponding sides. What does that give us? Remember that term? Scale factor. So scale factor is the ratio of two corresponding sides. So what ends up happening is the perimeter will be that exact same scale factor, that same ratio. All right, so let me just... So the ratio of the perimeters is the same thing as the scale factor. So if we know the scale factor, we know ratio of perimeter. All right. Go ahead, Sarah.
So we start by finding the scale factor?
We can start, there's a couple different ways that we can approach this problem. So I'm going to use ratio of perimeters using the ratio of two sides, or in other words, the scale factor, to solve this. So here's an example. We have, in this triangle, WBT, we have 12, we have 37, and we have 35. We know what the perimeter of this triangle is. Then we have this other triangle, HGK, smaller triangle. We only know one side. Okay, so there's a few ways we could do this. We could figure out, using proportions, we could figure out HG, and we could figure out HK, and then just add up all of those sides. But I'm going to use this theorem above, okay, to do that. So our scale factor would be comparing two corresponding sides. So we're going to compare 5 to 12. Okay with that? And that's, again, usually when we write the scale factor, I look back at the similarity statement. So it said GHK compared to TVW. So we have 5 to 12. Now, we also know what is the perimeter of triangle WBT. What do you get, Ari? 84. So we get that by adding up all the sides. Any questions so far? All right, so now what we're going to do is we're going to set up a proportion relating the scale factor. So we know that the triangles have a scale factor of 5 to 12. And then the perimeter of the larger triangle was 84. So where are we going to put that? In the numerator or denominator? Denominator. And then I'll put a P here. That's going to represent the perimeter of the smaller triangle. Okay? Yes, Tomer.
Oh wait, no, I got it. Sorry.
Okay, so again, all you have to do is compare two sides. So 5 to 12 equals the perimeter of the smaller triangle to the perimeter of the bigger triangle. And then cross multiply.
So is the answer 115?
Okay, so when we cross multiply, Josh, Reagan, what did you say?
Is answer 35?
35, yeah, because when
Do
we
you
cross
even need to
multiply.
cross multiply? Because you can see that 12 times 7 is 84, so 5 times 7 is 35.
Good. So you could just look at the ratios, and that's what Josh was saying. If you notice that 12 times 7 is 84, then you know the numerator is going to be 5 times 7, which is 35. That's fine. Okay with that?
So the scale factor is
The scale factor is 5 to 12. So the ratio of the perimeters is 35 to 84. But if we reduce 35 to 84, that will come out to 5 to 12. That's the scale factor. Ari.
So this is just a sort of way of doing proportions, like to each side and finding out what each side is.
Right. So I didn't have to find each smaller side. That was the shortcut. Could you have found each individual side and then added them up? Yeah, of course. So this is the perimeter triangle THK. Any questions before we move on? All right, let's take a look at the next triangle. So we want to find, so we're looking for the perimeter of triangle DEF. DEF is this small triangle, and DEF is similar to GFH. So I'm just going to trace GFH here. Those are the two triangles that are similar to each other. That was the similarity statement that was given here. So as long as we know two corresponding sides, so we can come up with a scale factor, and we know the perimeter of one of the triangles, we can figure out the perimeter of the other. So looking at this triangle, what is the perimeter here? Well, that's 2.5 plus 2 plus 4. So that will be 8.5. Okay, any questions? And then we want to compare two corresponding sides. So what would be the scale factor of these triangles? Go ahead. 3 to 2. So if you notice that 6 corresponds to 4, so our scale factor of triangle DEF to GFH would be 6 to 4, which is 3 to 2. So we know 3 to 2 is equal to, where does the 8.5 go, numerator or denominator? Denominator. Do we all agree? Now this one maybe not so obvious, because if you look at 2 to 8.5, right, it might be easier just to do the cross multiplying. So 2p equals 25.5. Tomer, what did you say you got? 12.75. So that's our perimeter of the other triangle. Again, you could have gone through the process of comparing each individual side and then added them up, or use this method.
Can we just see that it's going to be 14.5
Can you just see that what?
4.25 is 2 to 8.5.
Okay. That's what I was saying earlier. It might be a little not as obvious as the last problem because you have decimals, but you can still do that. Any questions? All right, let's turn to the next page. So that was the perimeters. Those we're looking at all the sides on the outside. Now we want to compare two similar triangles again, but we're looking at some specific segments. So in the first one, the special segments of similar triangles. So if two triangles are similar, then their corresponding altitudes are proportional to corresponding sides. What does that mean? Okay, well, what are the altitudes here? The altitudes would be, Brittany?
QA and UW.
Okay, so QA is to UW. And that will have the same ratio as any two pair of corresponding sides. So it doesn't matter, just pick a pair of corresponding sides and just make sure that you put them in the right order. So you could use QP to UT, QR to UV, PR to TV. Does that make sense? So I'll just pick two pair. I'll say PQ to T. So if I know the lengths of the altitudes in one side, I could find the corresponding side in the other triangle. That's how that would be used. Any questions on that one? All right, the next one. One of our other special segments are angle bisectors. Again, proportional to corresponding sides. Our angle bisector, in this case, is QB to UX. And someone give me, what would be a ratio on the other side, Roni? PQ over, what was the other one? TU. Okay, so far? These are just, again, these just fall under the category of those similar segments. We just have proportions. So we did altitude, we did angle bisectors. Next one is median. So we have the medians proportional to the sides. So raise your hand if you have that proportion. Give me an example of the proportion, Danny. QM over UI. Perfect. PR and TV. All right, let's look at example 2, where we have some examples of special segments here. Let's look at A. We have this one is an altitude, and this one is an altitude. So we're going to compare them to corresponding sides. So I'm going to give me, Danielle, give me a proportion. 12 over 13. You agree? Good. X equals 6 because we get 13x equals 78. So x equals 6. Any questions there? All right, for part B, we have, these are what type of segments that are drawn? The special segments? Medians. Why do we know these are medians and not angle bisector? Josh? Yeah, this is a midpoint here, and this is a midpoint. Okay, so our proportion would be, that's what he meant. Okay, so we have, somebody give me the proportion here. Brittany? X over 12, so we cross multiply, and we get, yeah, thank you. 15? All right, questions? So C is kind of an extension on the one with the angle bisector. This is an angle bisector, and we're looking at the segments that what's going on?
Point the thing up.
I know, but it's okay.
Maybe it's time for the computer.
I know. It's okay.
Yeah.
Oh.
Great Easter, right?
There we go.
Look at that. I'm not even touching the floor. I think it's time to.
Okay,
I'll edit this out later.
It's good time to put old Johnny out the pasture.
Editing out to say something.
We'll pause it here.
I will never say never.
No, no.
Here.
She's editing this out anyway.
I really